Hello everyone, welcome back to vishnusmartinfo. This is your track to physics mentor this side charusharma, and we are on the lecture 2 of mechanical properties of fluids. So in this lecture we will be discussing on barometer, manometer, Pascal laws and all those concepts. Okay. So in the last lecture we have discussed about the simple basic terms like what is fluid thrust, what is fluid in equilibrium, and how do we write pressure and so coming to the questions in the last asked in the last previous video, I haven't got a single answer. So still, if someone who has not watched the video, please, the link is mentioned in the description box below. Just go and watch the lecture 1. You will be clear with all the simple concepts and the simple terms which we are using in this chapter. And one more question for today's first question in today's class, question number 1 is, in the last video I explained you pressure is equal to force upon area, right? So we know that force is a vector quantity, area is also a vector quantity. So what about pressure? What about pressure? Is it scalar or vector? I want the answers in the comment box below. You can also answer in the chat box. Okay. Now let's move on and starting with today's lecture. So the first concept which we are going to discuss today is barometer. Okay, it is barometer. So what do you mean by barometer? So by using a barometer we can understand or come to know about pressure reading at a particular horizontal level. Okay, so at a horizontal level, how much is the pressure? You can come to know by using barometers. Now it is a very simple device, I can say. It can be constructed by ourselves also. So the typical barometers which you have in lab is something different. I am talking about the general case. Okay, so suppose this is your beaker, this is your container or beaker, whatever it is, and in this you have felt some fluid in this. Okay, some amount of fluid is filled in this container like this. Okay, now you have a test tube, inverted test tube kept like this in the fluid. Okay, now I will mark some points in this question. So here suppose this is point A, this is point B, this is point C, and this is point D. Okay, so 4 points are there. Now someone comes and asks you what is pressure at A, what is the pressure at D, what is the pressure at C, what is the pressure at B. So if anyone asks you like this, then what will be your answer? So here you should remember an important note point is pressure at horizontal level, at the same horizontal level, remains the same, equal. So same or equal means at the same, irrespective of the shape of container. So the pressure at a same horizontal level will remain the same irrespective of the shape of container. For example, now if I ask you what is the pressure at A, what is the pressure at B, and what is the pressure at C, means all the three are equal. Pressure at A must be equal to pressure at B, must be equal to pressure at C. Why is it so? Because according to the principle in barometer, the pressure at the same horizontal will remain same. So they are at same horizontal level, hence the pressure is same. But now someone's asked you that what is the pressure at D? What is the pressure here? Oh, sorry. Someone asks you what is the pressure here in D. Then what will be your answer? So for pressure at D, you should say that pressure at D is equals to pressure at the initial level So pressure at D here will be C. This is a closed area, right? This much is a closed area, right? This much part is a closed area, right? Any other color? Okay, so this much part is closed area. If this is closed area, means in closed area means there is no closed vessel. It is closed vessel. So for closed vessel, what will be the pressure at D? 0 only, na? Because there is no fluid, I can say, no presence of fluid over there. I am assuming that space to be vacuum. So hence pressure at D is equals to 0. Okay. But now there is one relation which we can find in the pressure of D. So there is a relation which we can find in pressure of D and pressure of CAB. So see, what is that relation is? For any like suppose this is your level, horizontal level. So what is the pressure here? If someone is asking you, this pressure is equals to pressure of the atmosphere plus this level is at what height plus H. If this level is at what height multiplied with the density into G. So P naught plus H rho G. Rho means in the density we are denoting with symbol rho. Okay, so density we are denoting with symbol rho. Suppose if this is your atmosphere, if this was your atmosphere like this is your atmosphere. So if someone is asking you what is the pressure at this horizontal level, then you should say the pressure at particular horizontal level is equals to pressure of atmosphere or initial pressure plus H rho G. Plus H rho G. So H is the height of that horizontal level from the point you are noting it. Second, D is the density, rho is the density, and G is the gravity, acceleration due to gravity. So similarly here, if I ask you what was, so I said you this is our horizontal level. So if this is our horizontal level, then if I ask you what is the pressure at C, for example, then what you must say, pressure at C is equals to initial or atmospheric pressure. So here atmospheric pressure can be noted by D because we assume that should be 0. It is in a closed vessel, no presence of fluid over there. So that is equals to pressure at D plus at what height this point is. So you can say that difference between D and C is H height. So the height between C point and D point is H height. So plus H dg. So rho density into G. I hope you understood that. So pressure at D, I told you before only that it is 0, means pressure at C is equals to H rho G. Pressure at C is equals to, because PD is equals to 0. So pressure at C is equals to H rho G. If pressure at C is equals to H rho G, so if I give you the values of H, and one more thing, one more concept. See, I said you that this is a closed vessel. If that was a closed vessel, let me draw the diagram again neatly. Again we will talk about all the concepts. Okay, so what I said you, that pressure, this was your vessel, this was your test tube, here was your D point. So firstly let us talk about point D, then here is your A, here is your B, here is your C. So let's first talk about D point. What did I say you, that due to there is no presence of fluid in this area, no fluid is present, pressure terms to be 0. So pressure at D point was 0, right? So I also said you that pressure at particular horizontal level, let me assume PA is equals to PB equal to PC. Pressure at particular horizontal level is equals to pressure at the initial point plus H rho G. We know that pressure at D is 0. So hence pressure at A, B, C becomes H rho G. So if I give you the values of H rho G, you will be able to find the atmospheric pressure. How can you find atmospheric pressure? Because see, C and A points are in term with atmosphere only, because this is the liquid over here. Whatever the fluid is filled only till here. But C and A points are in contact with the air, right? In the contact with the atmosphere. So nothing but P, pressure at A is equals to pressure at C equal to pressure at B. So these two points are in contact with air, I can say these are nothing but atmospheric pressures. Right or not? So if these are nothing but atmospheric pressures, we can find atmospheric pressure ka value by using this formula H rho G, because we already found it from the equations of barometer. So I have now that pressure at A equal to pressure at B equal to pressure at C. So that is H rho G. So H rho G. So I have given you height of mercury. So if this is, so these values if I calculate in a typical barometer, where mercury will be as a fluid will be filled in it. So height will be given as 76 centimeters of mercury, right? And not height, 76 centimeters will be given. Next, rho, density of the mercury, you know, 13.6 grams per cc, and gravity ka value you can take direct, roughly 10. So if you substitute 76 into 13.6 into 10, if you do H rho G, that turns out to be how much? 1.013 into 10 to the power 5 pascals. So this is how you find the values of pressures in barometer. So nothing, simple concept you need to apply. Two important points you need to note down and remember from now. What were those two important points? The first point was pressure at same horizontal level remains the same. And second point, closed area pressure to be neglected or taken as 0. Neglected or taken as 0. And what was the third point? Third point, that pressure at any particular horizontal level is equals to pressure of closed area plus H rho G. Or this can be, now here, no, this is not, in this case this was closed area, but this closed area terms always changes. So instead of writing closed area or initial points, this will always change with respect to question. So I am defining with P naught. So P naught plus H rho G. Okay. So these were the three important points which we learnt in today's class. Now next move on to the next topic, which is manometer. Now one question I want to ask, question number 2 of today's class, that was, if I give you this vessel and this vessel and this vessel. So I have given you 3 vessels and same fluid I am filling in all the 3. And I am drawing a line over here. Suppose I have point A here, point B here, and point C. What is the pressure relation? What is the relation between pressures at A, B, C? This is the question for today's class. Second question. Okay. Now don't tell me that this is not a straight line. Okay. Assume that is a very straight line. Okay. So these three vessels, what is the pressure relation between A, B, C? This is the second question. I want just now the answers in the live chat. Next, let's move on to the next topic, which is manometer. Okay, let's move on to the next topic, manometer. So for manometer, what it will be used to measure the pressure of a particular gas. So what will be there is, you will have an instrument. Suppose this is your closed flask. Then like this U-tube will be connected. Okay, like this U-tube will be connected. In this, what will be filled is gas. So in this, what is filled? Gas is filled. Okay. Now, and in this U-tube, one fluid, a type of fluid is filled. Okay. So now I will give you three different points over here. So first of all, the first point here is PC, which is in direct contact with the air. The second point is over here, PB. And the third point is PA over here. Okay. And from the picture itself, you can come to know that PA and PB are the same horizontal level. So, as PC is direct in contact with air, contact with air, can I say that PC is equals to P naught, which is atmospheric pressure? And as PA and PB are at same horizontal level, they are equal. Also, I said you initial point means P naught plus H rho G. Let me take the difference of height between C and B point is H. So, PA is equals to PB and PB is equals to P naught plus H rho G. Okay. So, if someone asks you what is the pressure of the gas, as you can see from here, gas is there and this gas is in contact with this A only, not directly. So, what is the pressure of gas? Is nothing but pressure at A. Now, how is pressure as A? You can find pressure at A is equals to P naught plus H rho G. So, from this, you can come to know the pressure of gas. This is only manometer. That simple it is. Okay. Suppose sometimes one more application in the same case, what they will give is, they will say that two types of fluid is, instead of one single density ka fluid, they will take two types of fluid. So what you should say is PA is equals to PB is equals to P naught plus H rho 1 G plus H rho 2 G. Okay, and according to the density, the heights of the one fluid will go up, which is lighter in density will flow up, and which is heavier in density will come down. So like suppose if there are two different fluids, one with a density rho 1 and one with a density rho 2. So suppose let me say this is lighter one and this is heavier one. So lighter one will stay up and higher density one will stay below. So the height occupied by them, this will be H1, this will be H2. Similarly, the heights will also change. So here H1 and H2 also you can put. Okay, when this case should be used, when instead of just I took this blue color fluid, now only one type of fluid I took. Instead of that, they take two types of fluid, means you should use this formula. Okay, you should use this formula, that PA is equals to PV is equals to P naught plus H1 rho 1 G1 plus H2 rho 2 G2. That simple it is. Okay. So in today's class we have learnt about barometer and manometer. That's it for today's class. a very 20 minutes short video. Just like, comment your feedbacks, comment your answers below down, and hoping for your support. Thank you very much. Have a good day. Bye bye. Take care. In next class we will come up with more interesting topics.